Mechanical components. Understanding mechanical components, compressors, condensers, and evaporators. Hello folks, welcome to this comprehensive lesson on mechanical components pivotal in the operation of refrigeration and air conditioning systems. This session will cover compressors, condensers, and evaporators, along with expansion valves, capillary tubes, and refrigerant flow control devices. Our approach will be deductive, providing detailed insights into each component's role and function within a system designed for professionals eager to enhance their understanding of these technical elements. Compressors. Compressors are referred to as the heart of the refrigeration cycle. They act by compressing the refrigerant, which changes its state from low-pressure gas to high-pressure gas. This energy transfer is crucial as it propels the refrigerant through the rest of the system. Types of compressors. Reciprocating compressors utilize pistons driven by a crankshaft to deliver gases at high pressure. They are robust and widely used in industries. Screw compressors use helical rotors to compress the gas. These are highly efficient for continuous operations. Rotary compressors feature rotating blades within a cylinder to compress gas, ideal for compact systems like household refrigerators. Centrifugal compressors employ a high-speed impeller to impart velocity to the refrigerant, commonly used in large installations. Condensers. Condenser is responsible for expelling the heat absorbed by the refrigerant from the interior of a building or system. The high-pressure gas released by the compressor is cooled down and condensed into a liquid state. Types of condensers. Air-cooled condensers use ambient air to cool and condense the refrigerant, common in domestic appliances. Water-cooled condensers utilize water circulation for cooling. Typically found in large-scale industrial applications. Evaporative condensers combine air and water cooling methods for efficient heat dispersion, often used where water is readily available. Evaporators. The role of the evaporator is to absorb heat from the space intended for cooling. It allows the high-pressure liquid refrigerant to expand and evaporate, turning back into a gas. Designs of evaporators. Plate evaporators feature flat plates that provide ample surface area for heat exchange, common in domestic refrigeration. Finned evaporators consist of metal fins attached to the coil, enhancing heat transfer rates. Typically employed in air conditioning systems. Shell and tube evaporators. Used in industrial settings, they allow for large volume exchanges through parallel tubes.
Expansion valves and capillary tubes. Expansion devices are critical for reducing the pressure of the refrigerant from high to low, enabling it to evaporate and absorb heat efficiently. Expansion valves and capillary tubes are two primary types used for this function. Expansion valves. These valves precisely control the amount of refrigerant flowing into the evaporator, thus regulating the pressure drop and temperature of the refrigerant. Types include thermostatic expansion valves TXVs. Automatically adjust the flow of refrigerant based on the superheat level, offering efficiency and protection against liquid slugging. Electronic expansion valves EVs. Provide precise control and flexibility, adapting to system conditions dynamically with the use of electronic sensors and actuators. Capillary tubes. Capillary tubes are long, narrow tubes that create a consistent pressure drop through simple passive control. These are most suited for small, fixed-capacity systems such as domestic refrigerators and window air conditioners. Refrigerant flow control devices. Efficient refrigerant flow control is vital for optimal system performance, ensuring the right quantity of refrigerant is present in the evaporator at all times. Key devices include solenoid valves, electrically controlled valves used to halt refrigerant flow when the compressor is off or during defrost cycles, maintaining efficiency. Flash gas bypass valves, designed to prevent flash gas from entering the evaporator, improving effectiveness in heat absorption. Understanding these components and their interactions is crucial for troubleshooting, design, and optimization of refrigeration and air conditioning systems. By mastering the details of compressors, condensers, evaporators, expansion devices, and control mechanisms, you enhance your ability to manage complex HVAC systems effectively, ensuring longevity and efficiency in your installations and maintenance operations. Executive Summary. Here's a summary of expansion valves and capillary tubes in refrigerators and air conditioning. Expansion valves. 1. Function. Reduce high-pressure liquid refrigerant to low-pressure liquid, allowing it to expand and become cold. 2. Types. Thermostatic expansion valves TXVs, electronic expansion valves EVs, and capillary tubes. 3. Components, valve body, orifice, and sensor TXVs and EVs. 4. Operation. TXVs use a temperature sensing bulb to regulate flow, while EVs use electronic controls. Capillary tubes. 1. Function. Restrict refrigerant flow, creating a pressure drop and allowing the refrigerant to expand. 2. Design. Long, narrow tubes with small diameters. 3. Materials. Copper, steel, or other materials. 4. Operation. Refrigerant flows through the tube, creating a pressure drop and allowing expansion.
Key characteristics. 1. Pressure drop. Both expansion valves and capillary tubes create a pressure drop, allowing refrigerant to expand. 2. Flow control. Expansion valves control flow based on temperature or electronic signals, while capillary tubes restrict flow based on their design. 3. Refrigerant compatibility. Both expansion valves and capillary tubes must be compatible with the refrigerant used in the system. Selection and application. 1. System design. Choose expansion valves or capillary tubes based on system design, refrigerant, and operating conditions. 2. Capacity. Select expansion valves or capillary tubes with the correct capacity for the system. 3. Installation. Follow proper installation procedures to ensure correct operation and prevent damage. Here's a summary of refrigerant flow control devices. Types of flow control devices. 1. Expansion valves reduce high-pressure liquid refrigerant to low-pressure liquid, allowing it to expand and become cold. 2. Capillary tubes restrict refrigerant flow, creating a pressure drop and allowing the refrigerant to expand. 3. Float valves regulate refrigerant flow based on liquid level in the evaporator. 4. Thermostatic expansion valves TXVs regulate refrigerant flow based on temperature. 5. Electronic expansion valves EVS regulate refrigerant flow based on electronic signals. Functions of flow control devices. 1. Pressure regulation. Regulate refrigerant pressure to ensure proper system operation. 2. Flow regulation. Regulate refrigerant flow to ensure proper system operation. 3. Temperature regulation. Regulate temperature to ensure proper system operation. Key characteristics. 1. Capacity. Flow control devices must have the correct capacity for the system. 2. Refrigerant compatibility. Flow control devices must be compatible with the refrigerant used in the system. 3. Pressure drop. Flow control devices create a pressure drop, allowing refrigerant to expand. Selection and application. 1. System design. Choose flow control devices based on system design, refrigerant, and operating conditions. 2. Installation. Follow proper installation procedures to ensure correct operation and prevent damage. 3. Maintenance. Regularly inspect and maintain flow control devices to ensure proper system operation. Here's a summary of expansion valves and capillary tubes. Expansion valves. 1. Reduce high-pressure liquid refrigerant to low-pressure liquid. 2. Allow refrigerant to expand and become cold. 3. Types: thermostatic expansion valves TXVs, electronic expansion valves EVS. 4. Components: valve body, orifice, and sensor TXVs and EVS. 5. Operation: TXVs use a temperature sensing bulb to regulate flow, while EVS use electronic controls. Capillary tubes. 1. Restrict refrigerant flow, creating a pressure drop. 2. Allow refrigerant to expand and become cold. 3. Long, narrow tubes with small diameters. 4. Materials: copper, steel, or other materials. 5. Operation: refrigerant flows through the tube, creating a pressure drop and allowing expansion. Key differences: 1. Expansion valves are more precise and can be adjusted, while capillary tubes are fixed orifices. 2. Expansion valves can be used with various refrigerants, while capillary tubes are often specific to a particular refrigerant. 3. Expansion valves are more commonly used in modern systems, while capillary tubes are often used in older systems or specific applications. In conclusion, understanding the mechanical components of refrigeration and air conditioning systems, including compressors, condensers, and evaporators, is crucial for designing, installing, and maintaining efficient and reliable systems. These components work together to facilitate the refrigeration cycle, transferring heat from one location to another. Key takeaways: compressors play a critical role in compressing refrigerant, raising its temperature and pressure. Condensers reject heat from the hot refrigerant gas to the surrounding air or water. Evaporators absorb heat from the surrounding air or water, causing the liquid refrigerant to evaporate. Proper selection, installation, and maintenance of these mechanical components are essential to ensure efficient system operation, reliable performance, energy savings, extended equipment lifespan, reduced environmental impact. By grasping the fundamentals of compressors, condensers, and evaporators, professionals in the HVAC and refrigeration industries can troubleshoot and repair systems more effectively, optimize system performance and efficiency, design and install new systems that meet specific requirements. Stay up to date with the latest technological advancements and best practices. Thank you for taking this lesson on fundamentals of compressors, condensers, and evaporators. We hope to see you again in the next lesson. Happy learning, folks!